So now let's take a look at how NESTINGWORKS and CAMWORKS can be used together to nest and create a CNC program for a wood router right inside SOLIDWORKS. And you can see here is a child's rocking chair, a wooden rocking chair. And what we can do is then go to the NESTINGWORKS tab, and I'll move a little more quickly since we're familiar with the process. And we can select the parts that we want to nest, and you can see those parts here. I might mention too, and let me put in the quantity here. Let's suppose that we want a set of 8 of these chairs for our dining room table, for example, or for a children's table. And I might also mention that there's options here too for grain direction, and one of those is also the texture direction that is specified on the SOLIDWORKS parts as well. I'll leave it set to none here, but I wanted you to know that you can also specify grain direction as the texture direction that is specified on the SOLIDWORKS parts. For the sheet here, the material that we want to use, I want to use a little larger sheet for these. Let's go up to, let's say, 10 foot by 8 foot or 3000 by 2400 millimeter sheet. We'll add that sheet to our sheet list here, and then we can go over to options. We'll just leave these set. We have 10 millimeters between the parts and 10 millimeters from the edge of the part to the edge of the sheet. For example, we need a little more room for our wood router bit to go between the parts. So leave those set, and then we'll go ahead and preview the nest. And you can see all the parts here are nested onto our 10 foot by 8 foot sheet, and we can go ahead now and generate the nested assembly. So this will create the SOLIDWORKS 3D assembly of the nested sheet of parts. Okay, so here we can see the nested sheet of parts in SOLIDWORKS again, and ready for CAMWORKS to machine. So we can go over to the CAMWORKS tab. You can see this time I have a router selected, and the coordinate system is set at the lower left corner again. So we should be good to go to extract the machinable features on the parts. And this will find all the machinable features on the rocking chair parts here. And then we can go ahead and generate the operation plan for machining and generate the tool paths, and then go ahead and simulate the machining. And let me turn this a little bit so we can see it a little better. And then go ahead and run the simulation. And now you can see the router cutting out each of the parts for the rocking chair. And you can see how quickly we're able to create a nested sheet of parts and machine those using a wood router. And this same sort of work could be done for cabinets or for furniture, other types of furniture, and it's very efficient for nesting and CNC machining using wood routers. You can see it machining the rest of the parts here. And there are also lead-ins and outs and all that here as well, to and overlaps to avoid witness marks. There we go. And there's little connectors as well for the seat on the rocking chair. Okay. And again, once we have the simulation complete, we can go ahead and post-process, give the file a name, and go ahead and generate the G-code for machining on the router. So now let's take a look at how NESTINGWORKS and CAMWORKS can be used in combination to manufacture an electrical enclosure like the one you see here. This is a sheet metal part that was designed in SolidWorks. And once NestingWorks is installed, there is a tab here that gets added to the SolidWorks Command Manager. So I'm going to go up here and use the icon on that NestingWorks tab to create a new nest job. Here I can select the parts that I want to nest. If I hit this button, I'll just select all of the parts, in this case both the body and the door of the enclosure. And we'll say OK here, and you can see that the parts automatically get flattened, so a flat pattern is created for each of the parts. And you can see here the parts listed within the NestingWorks dialog box. So here we can see the door, and you get a thumbnail of the part here. You'll also see where it has recognized the material and the thickness of the material automatically. So it has done that from the SolidWorks parts. So next, what we'd like to do is specify the number of assemblies that we'd like to manufacture. So I'm going to type in 15 here as the number of enclosures we'd like to make. So I'll type in 15 and then use a tab button, and you can see that it multiplies the number of parts by 15 as well. So in this area, I could also specify the grain direction and other information here. But let's just go ahead and proceed over to the Sheet Data tab now. And this is where I can specify what material I would like to use for this, for these parts. It has recognized that the material is 1 millimeter thick, and it is 316 stainless steel sheet that I'm going to be using. And it has also provided me with a standard library. This is a user-definable library of standard sheet sizes for manufacturing. So in this case, let me go to that library and let's pick this one here, the 2400 by 1200 millimeter sheet. And we will add that sheet to our sheet list. So our material is now specified. And next, what we can do is go over to the Options tab. Here we have several options. We can specify, for example, the distance between the parts is 3 millimeters. And let's make this part to sheet distance. This is the distance from the edge of the parts to the edge of the sheet. Let's also make it 3 millimeters as well. And you can also see here I have some other options for generating remnants, for example. So remnants, NestingWorks can generate remnants to be used in nests later, and it'll do that automatically, generate those remnants automatically. And then there's some other settings here. I'll just go ahead and preview the nest now. So here you can see all of the parts nested on the sheet that I specified, the 2400 by 1200 millimeter sheet that I specified. And here I have an option to be able to also output this as a DXF if I like, or I can just go ahead and generate a nested assembly of these parts. So let's go ahead and do that. And this will take a few seconds while NestingWorks generates that SolidWorks assembly. And here we see that SolidWorks assembly and all of the parts nested on the sheet here. And this is actually a 3D assembly of the nested sheet of parts. Go back to the top view here. And now what we'd like to do is create a CNC program on our laser to machine these parts. So let's go to the CamWorks feature tree here. And here I can select a machine, and you can see I have a laser machine selected by default. And what I could do here is go ahead and extract the machinable features so that we can begin programming the laser to machine these parts. So this will create automatically the feature tree for the machining, and CamWorks is able to automatically find all the machinable features on these parts. Now I can generate the operation plan for machining those features and then generate the toolpaths for machining. And now that the toolpaths have been generated, we can go ahead and simulate the machining. So if I rotate my view a little bit here and then start the simulation, you could see the laser going ahead and machining all of the parts on the sheet. And you can see it's also machining the details, including the vent here. If I zoom up a little bit, you can see the vents being machined on each of the bodies as well. So the laser is going through, or water jet, either one can be used for machining parts like these. And post-processor can be developed for any water jet or laser that you might have. And we also program routers as well. We'll talk about that in a little bit with the wood routers. And this takes just a minute to show us a simulation of each of the vents here. There's quite a few features there on those vents. And here's the vents on the other side of the enclosure. Those are the Abraum vents. There's also a hole at the center of each of those vents, and it's going through and machining the holes there now as well. And there was more we could do to optimize this program to reduce the cycle time even a little further if we were going to make large quantities of these parts. But I think you are starting to get the idea of how quickly you can generate a nested sheet of parts using NESTINGWORKS and also create a CNC program for machining those parts on your laser or water jet using CAMWorks. It's finished now, and we can go ahead and post-process the file to generate the G-code for machining. We give the file a name, and then we can step through the G-code or just go ahead and post-process, and this will generate the G-code for machining those parts on our laser.